Okay guys, so here's another video I would like to make, and just want to show you that for the conic sections and some of the geometric formulas that you need to know for calculus. So that's something you learn from geometry and also either algebra 2 or pre-cal. Okay, so we'll take a look at some of those. Okay, so let's start it off with conic sections. So we do have circles, ellipses, parabola, and hyperbola. So they're all considered conic sections. So circles, for the equation of a circle, we do have quantity of x minus h squared plus y minus k, quantity squared. So that equals r squared. So where h and k, the center, and r is the radius. So let's say we do have a circle. Okay. So h and k, that's the center. And the radius, well, it's always from the center to any point on the circle. Okay. And now, what about the ellipse? So we do have two different types of ellipse. So one is considered horizontal, and the other one is considered vertical. So for the horizontal ellipse, so as you can see that the major axis here, it's right along the x-axis, so that's why it's horizontal. And then the minor axis is right along the y-axis. And then for the vertical ellipse, so the major axis, so just need to swap that around. So this one B would be the major axis. And that's right along the vertical axis. And then A, the minor axis. And the formula for that, or the general equation for this, is x minus h, quantity squared over a squared, plus y minus k, quantity squared over b squared, and that equals 1. And then for the parabola, so we do have two types of parabola. One is considered vertical, could be going that way or upside down. And the other one is a sideways parabola. Again, h and k, that's the vertex. Okay, h and k. So for the vertical parabola, so the structure would be considered y minus k. So that equals 1 over 4p times the quantity of x minus h squared. Okay, so this one's for the vertical. And then for the horizontal, then that'd be the other way around. X minus h, so that equals 1 over 4p times the quantity of y minus k, quantity squared. Now for the value of 1 over 4p, so back to the previous video, so 1 over 4p, that's just the value of a. You can say that's a scale factor, but the thing is that the value of p, that tells you the distance from the vertex to the focus. From the focus to the vertex. And also the opposite direction, the distance, then that tells you the directions. So let's say that the focus right here, then that would be considered h, comma, k plus p. And then k minus p, the value for y, then that would be the directrix. So y equals k minus p. And then for the sideways parabola, pretty similar. So the distance, the value p, it shows the distance from the vertex to the focus. So for this one, it's considered h minus p, comma k. And then directrix would be the opposite distance. So x equals h plus b. And now, what about the hyperbola? So for the hyperbola, we do have the structure x minus h, quantity squared, over a squared, minus y minus k, quantity squared, over b squared, so that equals 1. Now compare and contrast. The equation for the ellipse and the hyperbola, they're pretty similar. The only difference is that one is plus, the other one's a minus. So you started with x first, this one is considered a horizontal hyperbola. And then for the vertical hyperbola, and that would be y minus k, quantity squared, over b squared, minus x minus h, quantity squared, over a squared. So that equals 1. So when it's horizontal, and the other one is vertical. And now there's something involved right here, besides the vertex, the center, well h and k is the center, and then the vertices. And also we do have the slant asymptotes. The slant asymptote. So the way to find the slant asymptote for this, well, there's an equation for the slant asymptote. If that's considered horizontal, so then that would be considered y minus k. So that equals plus minus b over a x minus h. Well, we got two of those. This one is going from left to right, the other one's from right to left. And then this one too for the slant asymptotes. So we do have, well, this one will be considered y minus k. So that equals plus minus a over b x minus h. Okay? So for the slant asymptotes, and then the slant asymptotes. Okay? So that's all the conic sections. So now, what about back to geometry? Any formula that I need to know for geometry? Well, there's tons and tons of formula that you learn from geometry. But the one I would like to focus here, it's all about the geometry, the one that we use all the time. By finding the surface area, volume, with all those three-dimensional shapes. So things that you learn from geometry, so let's say like sphere, rectangular prism, hexagonal prism, pyramid, things like that. So let's say that we have a sphere. So the way to find a volume for this is 4/3 pi r cubed. And then the surface area is 4 pi r squared. Okay, so that involved with radius. Again, volume, 3-dimensional. That's why you see that r to the power 3. Surface area, 2-dimensional, because that's all flat. So it's r squared. And now, what about a cylinder? So the way to find a volume, then that would be considered pi r squared, the area of the base, because that's a circle, times the height. Okay? And then the surface area, that's considered 2 pi r, the circumference of the base of the circle, times the height. And the next one I would like to talk about, then that would be considered a cone. The way to find a volume, so it's 1/3 pi r squared. Again, pi r squared, that's the area of the circle for the base. So 1/3 times the height. Well, the reason why it's 1/3, because that 1/3 of the volume of the cylinder, that's considered a cone. So let's say that you try to cut this off. So here's 1/3, 1/3, 1/3. And that would be considered 1/3 of the volume of a cylinder. And then the surface area for this one would be considered 2 pi r times L. Well, L, that means the slant height. Slant height of the cone. And then plus pi r squared. Okay, so this one gotta be a little bit careful the way to find the slant and height. Now normally, if that's not given, guess what we can do? We can use the Pythagorean theorem to find the slant and height. So that means this one is showing r squared plus h squared equals l squared. Okay? So we got a sphere, we got a cylinder, we got a cone. Let's see what else that we have. What about a prism? So let's say that we have a triangular base prism. Okay, so let's say we do have this. So it's a triangular base prism. So this one's kind of like tilted a little bit, so let me just resketch the figure. Okay, so we do have a triangle, top and bottom. Okay, so it's kind of like a piece of cake. Well, it's not easy at all, but it's a piece of cake right here. Okay, so let's say we do have A, B, and C. And here's the height. Okay? So the way to find a volume for this triangular base prism. So the way to find a volume, so you started with the area of the triangle down the bottom. So the way to find the area of the triangle, so let's say the height's not given, we can use the Heron's formula. If you remember the Heron's formula, so that one is considered S times square root of, well, it's actually square root of S times S minus A times S minus B, and then times S minus C. Okay? And normally the area of a triangle, the height's given, so it's 1/2 times the base times the height. So it all depends. So let's say this height is given. So this one should be capital H because that's the height of the prism. And that'll be 1/2 times base times the height. So the way to find the volume for this triangular base prism, it's the area of the triangles of the base times the height, capital H. Well, sometimes written as capital B times the height. So it's just want to generate all the stuff together. So it's 1/2 times B times H, the height of the triangle of the base, and then times the capital height, the height of the prism. So we'll just put the notes on this. The height of the prism, and this one is the height of the base, or the triangular base. Okay? So now let's see what else that we need to know. Another one that would be considered hexagonal prism. Okay. So for the hexagonal base prism, so let's say we have a hexagon, top and the bottom. So going this way. So let's say we have something like this. Okay, hexagonal base prism. Excuse me. Hey, Miss Clark? Yeah, that's right. Alright, I'll see you later. Bye. So for the hexagonal base prism, so let's say we do have a polygon, the side length of the base edge, and then the height of the entire prism. So the way to find the volume for this, again, it's always the area of the base times the height. But now it's a hexagonal base. So the way to find out the area of the hexagon, it's always 1/2 times the apothem. The apothem of the base. Again, A, that stands for the apothem, which is the height of the triangle. Try to draw the triangle here. And then times the perimeter of the hexagon. So P is the perimeter. And then the height of the prism. Okay, so 1/2 times the hypotenuse times the perimeter times the height of the prism. Now, what about the way to find out the surface area for this? Now, the way to find out the surface area, so we need to find out the area of the hexagon. We got both of them. So it's the hypotenuse times the perimeter. Because the 1/2 times 2, it just cancels out. It's just 1. So that takes care of the base, top and the bottom. But now, what about the side? So the way to find out the surface, well, the lateral area, because that part is considered the lateral area. So the way to find out the lateral area, then that will be considered perimeter. The perimeter of the hexagon times the height, pH. Okay. So the one that we just went over, we do have the volume for this sphere, surface area, volume, sphere of the cylinder, cones, and then the triangular prism, and then the hexagonal base prism. And those are the central formula that you need to know before taking calculus. Okay? So thank you for watching the video today.